Hi students, hope you are doing good. So, today we are going to discuss a new topic from the chapter Forces of Fluids in class 9 Physics. Let's move on to the topic. Now, look at this experiment by dipping a narrow straw in a glass of water. What can you observe about the level of water in the straw as compared to the water in the glass? What would be its reason? We have observed that when we dip the straw in the glass of water, there was a difference in the level of water in the glass and also in the level of water in the straw. That means the water has climbed up the straw. Now, observe the burning of this kerosene lamp. How the kerosene reaches the wick of the lantern and helps in the burning. Does there any rise in the kerosene through the wick of the lamp? In both of the experiments, we have observed the rise of liquids. This property of liquid is explained as capillarity. The rise or depression of liquid in a narrow tube or a minute hole is capillarity. The capillary actions of liquids are usually observed in our daily life situations. When we use paper towel to mop up water or in preventing the wilting of flowers kept in the vase filled with water, we are using capillary action. It is the capillary action of wick which maintain the supply of oil to keep the flame glow. However, the liquid performs the feat of capillary action depending on the cohesion and adhesion. The attraction between the molecules of same type is called cozy force. The example for cozy force is the attraction between the water droplets. Adhesion is the force of attraction between molecules of different types, and the example for the adhesive force is the attraction between water and a glass. When we write the blackboard with a chalk piece, the same adhesive force is observed. Now, let us look at how cohesion and adhesion influences the capillary action. Here, capillary tubes are dipped in water and mercury. Observe the level of water and level of mercury in each tubes. On observing the level of water, we could see that the surface of water is curved downwards, and this is because in water the adhesive force between the water and glass is greater than the cohesive force between water molecules. This results in the capillary rise of water. In the case of mercury, the surface of mercury is curved upward. The adhesive force between the mercury and the glass is less than the cohesive force between the mercury molecules, and this resulted in the capillary depression. Now, observe the figure and compare the capillary rise in each tube. In which tube capillary rise is greater? In which tube capillary rise is smaller? From the figure, we could understand that the capillary rise is greater in the tube with small diameter and capillary rise is lower in the tube with large diameter. This is because when the diameter of the tube decreases, the weight of the liquid it contains also decreases. And the weight of the liquid is supported by the adhesive force. We have already discussed that the capillary rise occurs when the adhesive force is greater than cohesive force. Thus, capillary rise is greater in tube with small diameter and lower in tube with large diameter. So, we can conclude that diameter of the tube influences the capillary rise. So, let us conclude what we have discussed today. We have discussed about the property of liquid called capillarity. The rise or depression of a liquid in a narrow tube or a minute hole is capillarity. The attraction between the molecules of same type is called cohesive force, and the attraction between the molecules of different type is called adhesive force. Liquid performs the feat of capillary action depending on the cohesion and adhesion. Capillary rise occurs when the adhesive force is greater than cohesive force, and capillary depression occurs when adhesive force is less than cohesive force. The diameter of the tube influences the capillary rise. So, today we have discussed about the property of liquid called capillarity. Hope you understand well. So, let's check your understanding level. What is capillarity? A capillarity rise occurs when, with increase in diameter, capillarity rise. Give an example for adhesive force.